Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Let's have a discussion on this question. Question of the year 2016, majoring paper variance 43. For this question, it's related to the chapter of forces and equilibrium in the mechanics paper. Have a look at the question here. A particle of mass 15 kg is stationary, means not moving, on a rough plane inclined at an angle of 20 degrees to the horizontal. The coefficient of friction between the particle and the plane is 0.2. A force of X Newton acting parallel to the line of greatest slope is used to keep the particle in equilibrium. So it's not moving. Show that the least possible value of X is 23.1, correct to 3 significant figures, and find the greatest possible value of X. Let me sketch the diagram. So it's an inclined plane with 20 degrees to the horizontal. So for that particle, it's 15 kg. So the downward force here should be 15 kg. And there is a force of X Newton acting on the particle. So let's say the X Newton is over here. So it mentioned that the force of X Newton is parallel to the line of the greatest slope of the plane. That means it's parallel to the plane. Okay, so for inclined plane, the first step, what we need to do is we have to resolve this component, the weight here. So let's resolve it into parallel to the plane and perpendicular to the plane's direction. So for the force that is perpendicular to the plane's direction, it should be 15 times 10. It should be mg. So it's 150 Newton cos 20, as the angle here is actually 20 degrees. As for the force that is parallel to the plane, it should be 150 sine 20. For the X Newton here, there's no need to resolve it because it's already in the direction that is parallel to the plane. And is there any other forces? Yes, since there is a contact between the particle and the surface here, that means there should be contact force, which is the friction and the normal. Let's talk about the normal force first. So the normal force should be perpendicular to the plane in this direction. I name it as R. And what about the direction of the friction? It depends on whether you apply the least force X or the greatest force X. So let's do for the first one, the least X. So when you apply least force X Newton to maintain the particle in equilibrium, it means that this particle should be on the point of moving downwards because you applied with the least force. On the point of moving down. So when it's on the point of moving down but it's not moving because of the word equilibrium here, then the friction should be in opposite direction, which is here. Oh, sorry. It should be here because it's on the point of moving down, so friction should be moving up. Then we need to form two equations. One equation is parallel to the plane's equation. The other equation, it should be perpendicular to the plane's equation. So let's have a look at the one parallel to the plane. So the forces that are parallel to the plane, they are friction, X Newton, and mg sine theta. Since the particle is in equilibrium, the upward force should be equal to the downward force. So the force going upwards is x Newton, and the friction, it should be equal to the downward force, which is 150 sine 20. So from here we can actually figure out the friction is equals to 150 sine 20 minus x. As for the perpendicular direction forces, what forces we have? We have the r and the mg cos theta. So the upward force again should be equal to the downward force because the particle is in equilibrium. So from here we can conclude that the r is equals to 150 cos 20. How are we going to link the friction and the r? There is a formula: friction equals to mu r. So we just sub in the friction, which is 150 sine 20 minus x equals to mu. What's the mu here? It's given in the question, 0.2. So it's equals to 0.2 r, 150 cos 20. So from here, we can actually solve for the x. It should be equals to 23.1. So this is actually the least x. So for now, let's move on to the second part of the question, which is about finding the greatest possible value of x. Let me jot down here. Greatest x. So the word greatest means you are pushing in this direction with the greatest force, and you have to maintain this particle in equilibrium, means not moving. And if you apply with the greatest force to push this particle up, which means this particle should be on the point of moving up or down. It should be on the point of moving upwards. If the particle is on the point of moving upwards, this will change the direction of the friction here. So now the friction is no longer moving upwards, it should be moving downwards as the particle is on the point of moving up. And for the r, it should remain the same. The r force is not affected. So now let's form an equation for the forces in parallel to the plane's direction. So notice that what forces we have in the direction of the plane. We have friction here, we have x Newton, and we have mg sine theta. So let's form an equation on that. Since the particle is in equilibrium, so the upward force should be equal to the downward force. So the force that is going upwards is the x Newton, should be equals to the downward force, which is friction, and the 150 sine 20. So from here you can actually figure out that the friction is equals to x minus 150 sine 20 degree. As I mentioned earlier, for the perpendicular directions equation, it should be same as the previous case. So the r, upward force, is equals to the downward force, which is 150 cos 20. So again, we can link the friction and the r by using this formula. Friction equals to mu r. So you just need to sub in the x minus 150 sine 20 degree equals to the mu, which is given in the question, 0.2, and the r is 150 cos 20. And eventually the x should be equals to 79.5, and this is our greatest x. That's how we solve for this question when they mention about the word greatest and least value of x.
That's all for today's video. if you're interested in more genuine sharing by other geniuses. Please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.